if you have a binomial squared, like x minus 5 squared, we have to remember from our exponents unit what an exponent means. So whenever you have something squared, it really means repeated multiplication. It means the same thing multiplied by itself. And so you'd have x minus 5 times x minus 5. And every time you have this question, you will rewrite it as x minus 5, x minus 5. That'll be step 1, just writing what the exponent means. Then once you have that x minus 5, you can draw all 4 of your arrows again and multiply and just practice x times x, x squared. X times a minus 5, minus 5x. Minus 5 times x, minus 5x. Minus 5 times minus 5, plus 25. Do we have any like terms? Minus 5x, minus 5x. So we simplify those. Minus 5 minus another 5 gets you to minus 10. And so another thing that algebra does for us while we're doing it is that it practices some of the skills that you've done for a long time. Notice, what did we have to do? We had to do 5 times 5. We're practicing our mental math skills to get 25. In fact, we had to do negative 5 times negative 5. So not only were we practicing our mental math skills, we were also practicing our skills with integers. So when something is squared, we're not just squaring each thing separately. Hello. It is February 19th. All right. So first step that we'll always do in these is we'll say, I know that squaring means repeated multiplication, and you'll write out m plus 4 times m plus 4. Then draw all your arrows. Go through one arrow at a time. M times m, m squared. M times 4, plus 4m again, plus 16. And then do we have any like terms? 4m and 4m. Putting those together are 8m's. And that's your final answer. Okay, I would like you to try the next two on your own. Okay, step 1. Check, did you write out the repeated multiplication correctly? Okay, step 2. Did you draw arrows from the first, the outside, the inside, and the last? Then do each of the arrows. First ones would be x times x, that's x squared. Outside ones, inside ones, negative 6, negative 6. Yes? And then do we have any like terms? And so putting those together makes? Negative 12. Awesome. So none of the multiplication is super big, none of the numbers, but we just have to remember sort of this new rule for foiling. I can. You're good? So a good question came up with this one. So even though it's a 2x in front, it's still one term. We go from the 2x to this one and the 2x to this one. No extra arrows are needed. We only go, the only thing that separates terms are adding and subtracting. So to begin with, the squared means repeated multiplication. So that's why we have the 2x plus 3 twice.
But how do we add like letters?
The letter, you don't. You can't put it together yet. So we're learning the rules for algebra.
When she drew the line to the two x's, I just don't add them?
This first line here from the 2x to the 2x means you're going to multiply them. And the rule for multiplying 2x to multiply your numbers, 2 times 2 would be 4. Multiply your variables, x times x would be x squared. Then you would do 2x times 3. So 2 times 3 is 6, and then we have an x. Then 3 times 2x, well, 3 times 2 is 6, and then you have your x, and finally 3 times 3 is 9. It's getting close to the answer. We're not quite done yet because these two are like terms. I'm going to help you guys with the setup here because this one is complicated. First of all, we've got the squared. So the very first thing I would do in this question is I'd rewrite everything and I would take that squared and write out repeated multiplication. Okay? So I've only done that squared thing. Now, whenever we have a number in front of brackets, we distribute. So I'm going to have this arrow going from that one to that one. Whenever we have two binomials together, we FOIL. So this arrow here, arrow here, arrow here, arrow here. Another two binomials, arrow, 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 arrow. So now I'm going to give you guys a little bit of a head start. Let's see if you got the next line right. 3 times x, 3x, 3 times negative 2, negative 6. X times x, x squared. X times negative 3, negative 3x. 1 times x, x. Negative 3, and then x squared minus 4x minus 4x plus 16. Wow. Did you get all those numbers? Okay. Now, do we have any like terms with 3x? No, no, yes. Yes, no, no, yes, yes. Do we have any like terms with the minus 6? No. Minus 3 would be a like term with minus.
Wait, what?
And
Wait for 1 second.
Please slow down.
slow down.
Wait for 1 second. What
Oh
happened?
my God, slow down.
Yes.
And the last like terms,
4x.
x squared there and x squared there. So let's do the black ones first because there's only one of each of them. If you have an x squared plus an x squared, you would have how many x squareds? The x squared plus the x squared, I'll even write the answer in black. You would have 2x squareds. Well, like terms, right? 1x squared plus 1x squared would be 2x squared. Okay, now let's do the green ones next. If you have 3x, you subtract 3x, you'd be at 0. You'd be at 0. 0 x's. Plus 1x, now you're at 1x. Minus 4. Negative 3 minus another 4. Negative 7 x's. And finally, the red ones, the numbers. You're at minus 6. You subtract 3. Minus 9. Add 16. Close. 7. Should I put one like that on your test? Oh, okay. That's too much.
If you split half of it in half,
How about if I just do the little parts of it? That would be okay, right? Just the 3x minus 2, just these ones, just those ones.
split it in half and do that.
Then that would be okay.
You know, if you want to get to have a mental breakdown in your class, yeah, go ahead. I will actually have a whole mental breakdown.
You will not have a mental breakdown.